There are few ideas more powerful or more dangerous than believing the impossible is only temporary. Throughout history, humanity has faced frontiers we thought impassable. Oceans too wide, mountains too high, skies unreachable, space unthinkable. And each time, someone stood at the edge, looked beyond the known, and decided to go. Today, that someone is SpaceX. And the destination? Mars. For decades, Mars has symbolized the next chapter of human exploration. A world with mountains taller than Everest, canyons deeper than any on Earth, a planet with ice at its poles, seasons like ours, and the tantalizing possibility of life, past or present. To reach it is a dream shared by nations, scientists, storytellers, and visionaries. But now, one company has built a rocket not just for orbit, but for Mars itself. Its name is Starship, and the question the world is asking, can it really get us there? At first glance, Starship looks like something from science fiction, smooth, reflective, towering above the Texas desert like a monument to ambition. But behind its shining surface is a machine of radical design and purpose. At 120 meters tall, with the power to carry over 100 tons into space, Starship is the most powerful rocket ever conceived. Its two stages, the Super Heavy booster and the Starship upper stage, are both designed for full reusability. No more single-use boosters or disposable stages. This vehicle is built to fly again, and again, and again. Every element has been designed with Mars in mind. Its engines, 33 Raptor engines on the booster, with several more on the ship, burn liquid methane and liquid oxygen. Why methane? Because on Mars, those ingredients can be made from the planet itself, from CO2 in the air and water ice in the soil. This isn't just a rocket to go to Mars. It's one that's planning the return trip, too. But Starship isn't just about where we go. It's about how we go. Fully reusable, massively scalable, designed not for a single mission, but for an era. If it succeeds, it could change everything. Space is expensive, painfully so. Launching a single kilogram into orbit can cost thousands of dollars. Multiply that by the needs of a Mars mission, life support, equipment, shielding, fuel, water, food, and you're staring at a logistical wall that no nation on Earth can easily scale. But what if you could reuse the rocket? Not just a part of it, not just the boosters, the entire thing. What if every flight didn't end with a crash into the ocean, but with a controlled landing, ready to fly again the next day? That's the heart of SpaceX's philosophy. Build rockets like aircraft. Make them fly often. Make them cheap. Make them reliable. Falcon 9 proved it was possible, landing boosters vertically again and again. Starship takes that lesson and supercharges it. A fully reusable transport system. 100 tons to orbit. 100 passengers to Mars. No waste. No destruction. Just rotation and refueling. If they can do it, it changes the economics of space entirely. Mars stops being a one-time miracle and starts becoming a regular destination. But Earth orbit is just the beginning. Mars is far, unimaginably far. At its closest approach, the red planet is still 140 times farther than the Moon. Even at top speed, it takes Starship 6 to 9 months to get there. And in between lies a vacuum, cold, silent, and unforgiving. A spacecraft making that journey must be more than a rocket. It must be a self-contained world, a fortress against radiation, a home for its crew, a laboratory, a greenhouse, a backup for human civilization. It must endure microgravity for months, protect its passengers from cosmic rays, carry enough supplies to survive, adapt, and troubleshoot in the emptiness between planets. And when it arrives, the hardest part begins. Landing on Mars is notoriously difficult. The atmosphere is just thick enough to cause friction, but too thin to slow down a heavy spacecraft. Parachutes won't work. Air brakes are limited. Starship plans to use retropropulsion, slowing its descent with its own engines, flipping upright in midair and landing on powerful legs. It's been tested on Earth. It's worked and sometimes failed. But on Mars, there will be no room for failure. Because you don't get to crash and try again when you're 400 million kilometers from home. There's a reason we've never brought astronauts to Mars. Getting there is hard, but coming back is harder. A round trip to Mars requires an enormous amount of fuel. Fuel you'd need to carry from Earth, unless you make it there. That's the cornerstone of SpaceX's Mars plan. In situ resource utilization, or ISRU. On Mars, there's CO2 in the atmosphere and water in the soil. Combined, they can be used to synthesize methane and oxygen, the very fuel Starship runs on. This is more than chemistry. It's logistics, engineering, survival. You must mine the ice, extract the gas, power the plant, store the propellant, all in a brutally cold, low-pressure environment, using machinery that must work perfectly. No one's ever done this off-world before, but SpaceX is betting that we must. Because a one-way trip is a stunt. A round trip, repeated, sustainable, is colonization. And that means not just building starships. It means building refineries on Mars. Beyond steel and fire, there's another challenge waiting on the voyage to Mars. Us. Our bodies were built for Earth. Our minds for its rhythms. Gravity, blue skies, the closeness of others, the comfort of help just a phone call away. In space, all that disappears. The gravity is gone. Fluids pool in the upper body. Bones weaken. Muscles atrophy. Immune systems behave oddly. And radiation never sleeps. On Mars, gravity is only 38% of Earth's. No one knows the long-term effects of living in that kind of environment. Not for weeks, but for years. Then there's the mind. Imagine being sealed in a small craft for months, staring out at blackness, knowing you are farther from Earth than any human has ever been. That no rescue is coming. That if something goes wrong, you're on your own. Psychological stress is no side effect. It's a mission risk, just like a faulty valve or a misfired engine. For a mission to Mars to succeed, we must prepare not only rockets, but people. So when will Starship carry people to Mars? Elon Musk has suggested ambitious timelines, the mid to late 2020s. Most experts say the 2030s are more realistic. NASA, meanwhile, is focused on the moon, with Artemis serving as the proving ground for deep space survival. But SpaceX moves fast. Prototypes are already being built and tested. Some have flown, some have failed. All have taught something. Launch towers rise in Texas. Starbases hum with construction. Contracts are signed. Fuel depots are planned. Lunar missions are on the docket. But Mars? Mars is still a leap. To go there, we need more than a rocket. We need a fleet. We need infrastructure. We need vision backed by relentless execution. And we're not there yet. But step by step, test by test, the path is forming. SpaceX Starship is not just a machine. It is a statement that we are not content to remain on this one fragile world, that we can and must become interplanetary, that we can face the odds, defy the doubts, and go farther than anyone has gone before. Will it reach Mars? The answer is not certain, but the attempt, the effort, the vision may be the spark that gets us there. Because the future is not a place we discover, it's a place we build, one launch at a time.